So hello students, today we will discuss an example where we would show that our given function is not a distribution function because it is not satisfying the property of being right continuous. So the function fx of function is not a distribution function because right continuous. So the problem says that fx which is defined as 0 for x being less than 0, x squared by 2 for x lying between 1 and it is also 1 plus 2 plus bracket and fx is defined as 6 by 7 plus for x so and 1 for all x greater than equal to 3. So this is the way the distribution function is defined. Now we will check the properties of a distribution function, whether this function is satisfying those properties or not. So first of all, you will see whether f is increasing or decreasing function. So we can see f at 0. So f at 0 is, we can say this, so it is 0. f of f at 1. F at 1 is given as x squared by 2, so it is 1 by 2. Now f at 2. So f at 2 we are given as 1 over 2 plus 2 minus 1 to the power cube divided by 3, which is 1 by 2 plus 1 by 3. So it is nothing but it is 5 by 6. And also f at 3 we are given as 1. So we see that the distribution function value of f is increasing from 0 to 1 by 2, then 5 by 6 and 1. So f is increasing function, is a non-decreasing function. So we have settled this claim that fx is a increasing function. Now we will check whether what is the value of f of x at minus infinity. So f of x at minus infinity we are given as 0. So this property is also satisfied. And also we will check f of x at plus infinity. So we are given here, we are given that f of x is 1 for all x greater than 0. So this property is also satisfied. So in this way we have checked three properties of the distribution function and all are satisfied. Now we will check the right continuity of the function. So now let's check the continuity at f at 0 is 0 and f at 0 plus, which is limit h tends to 0, limit of f at 0 plus h. So where this 0 plus h will lie? It will lie at x square by 2. So which will be h square by 2, which will be 0 as h tends to 0. Now similarly we will check the what is the value of function at f at 1. So f at 1, it is defined as 1 square by 2. So it is nothing but 1 by 2. Now to check the right continuity f of 1 plus 0, we will take limit h tends to 0 f of 1 plus h. And where this will lie, 1 plus h means x is lying in this interval. So this interval, that is the probability, it is 1 by 2 plus, if we will substitute 1 plus h in place of x, so it will become x 1 plus h minus 1 to the power cube divided by 3. So this 1 cancels out and we are taking limit. So once we apply the limit, it will be 1 by 2. So we see that f at 1 is right continuous. So we have checked at f is equal to 0 and f at 1. Now we will check what is the value of f at 2. So we are given that for x is for f at 2, we will see this particular domain. So 1 by 2 plus, it will be 2 minus 1 to the power cube divided by 3. So it will be 1 by 2 plus 1 by 3. So this comes out to be 5 by 6. Now we will check for the right continuity f at 2 plus 0. So limit h tends to 0 f at 2 plus h. So f at 2 plus h means greater than 2. So this will lie in this interval. So we see that it is nothing but it is 6 by 7 plus 2 plus h minus 2 to the power 4 divided by 7. So this cancels out, and if we impose limit h tends to 0, so this comes out to be limit h tends to 0 6 by 7 plus h to the power 4 divided by 7. So when we apply the limit h tends to 0, this comes out to be 6 by 7. And here we have observed that f at 2 is, which is not equal to 5 by 6. So the condition of right continuity has been violated here. So we say that f is not a distribution function as it is not right continuous at x is equal to 2. So this is a particular example where we show that a given function is not a distribution function because it is not right continuous. So you can jot down this example. So I hope you have noted down. Now we will take the certain events and we will write their probability in terms of distribution function. So this particular formulation will help you in assessing how you can obtain the probabilities with the help of a distribution function. So here we define the event. And corresponding probability. In terms of df. So first we say f of x is less than equal to a. X is greater than a. X is less than a. X is greater than equal to a. And probability of x is equal to a. So we know that this is nothing but f of x at a. Now, to obtain this probability, we will see that it is 1 minus f of x at a. Since equality has been obtained in this, so we will we take the complementary event and we will say that this probability is this 1 minus f of xa, which is probability that 1 minus probability of x is less than equal to a. So which is the probability that x is greater than. So this way it has been defined. Now for this we will see that probability of 1 minus, it is f of x at a minus, because we are not including the point probability that x is less than equal to a. Okay. Now this is the probability that probability of x is greater than equal to a, which is nothing but 1 minus probability of x is less than a, and which is 1 minus f of x at a minus. Now, what is the probability of this? Probability of this is probability of x is less than equal to a minus probability of x is less than a. So, which is f of x at a minus f of x at a minus. So, this is the way we can define the probabilities of particular event. Now, if we take the ranges for these probabilities, suppose A is lying between x is greater than equal to b. Second is x is lying between b and a. And x is lying between b and a with equalities. And the last event is x is. So these are the four possibilities for 2 points. So by the definition of distribution function, this particular we have already defined in the definition of distribution function. So this is nothing but f of x and b minus f of x at. Okay. Now for fx is lying between this is nothing but it is f of x b minus, because equality is not here, and also f of x at a. Now for the equality here we are getting equality, so we will write f of x at b minus f of x, since equality is here, so we have to exclude this point, so we will take a minus. Okay. Similarly, for the last event we will say, since equality is not given, so f of x b minus f of x at a minus. So these are the this is the way we write the event in terms of x and their corresponding probabilities in terms of distribution function. So this question was asked by in the district statistical officer exam by conducted by UP government. When I So this question was asked in the year 2003 when I appeared in this exam. So now I will take you to some more examples, and where with the help of these inequalities, we will obtain the distribution corresponding probabilities for given random. So you can note it down. So this example says, let fx be defined as zero for x less than 0, x by 4 for and 1 by 2 if x is lying between 1 and 2 and x by 12 plus 1 by 2 for x lying between 3 and 2 and it is 1 for x greater than equal to 3. So what we are doing, we have been asked to obtain is A, probability of x is less than equal to 2, B, probability of x is equal to 2, C is probability that x is lying between 1 and 3 with the equality at x is equal to 1. D portion is probability of x is greater than 3 by 2. E is probability of x is equal to 5 by 2. So this is a very particular case, and F we are given as probability that so we have to obtain by using the distribution function these probabilities. So let's take the example first. Probability of x is less than equal to 2. So where this x is less than equal to 2 will be lying? So this is for x is lying less than equal to 2, the probability is 1 by 2 because x is less than equal to 2 is here and the corresponding distribution function says the probability is 1 by 2. Okay, for second question, probability that x is equal to 2. So for x is equal to 2, we will have to take the distribution function f of x at 2 minus f of x at 2 minus. So what we will get? So we will get the fx at 2. Fx at 2 is 2 by 12 plus 1 by 2. Okay, it was for x equal to 2. This is the function is defined as this. So I have substituted x is equal to 2 in this. So 2 by 12 plus 1 by 2 minus f of x is less than 2. So this probability is we are given as 1 by 2. So this answer is 1 by 6. So C part which says probability that x is less than 3 but is equal to 1. So x is less than 3. So here x is less than 3. So 3 by 12 plus 1 by 2 minus f of x at less than equal to 1. So less than equal to 1, this probability is for this, because of this, it is half. So this cancels out and the answer is 1 by 4. So let's see the D part. D part says x is greater than 1 minus probability of x is greater than 3 by 2. So always we should try, if we are given the inequality in the greater than type, then we will first reduce it to the less than equal to type. So it will be nothing but probability of x is less than equal to 3 by 2. So 3 by 2 is 1 by 2. 3 by 2 is 1.5. So 1.5 is lying in the region this. Okay, so probability is 1 by 2. So this probability is 1 by 2. Okay, now we will see D part we have done. Now E part says probability that x is equal to 5 by 2. So this is very useful example. Here we are not given any critical point corresponding to 2.5. So the probability that x is equal to 5 by 2 minus x minus x is less than equal to 5 by 2 minus is equal, so we get this answer as 0. Now the F part says this probability of x lying between 7 and 2. So we know that from this, for all x greater than 3, the probability is 1. And what is the probability of x is less than equal to half? So probability of x is less than equal to 2, less than 2, sorry. So this is half. So probability of x is less than, for probability F part answer is 1 by 2. So this is the simple way to represent how the different probabilities can be obtained from corresponding distribution function. So you can note it down, and then we will take the next example for this distribution. For So to see this on the C part, we are seeing f of x is less than equal to 1. So this should be 1 by 4 instead. So this particular will be 1 by 4. So this answer will be slightly changing, and we will be getting 3 by 12 plus 1 by 4. So 12, 3 plus 3 is 6 by 2, which is 1 by 2. Since we are given here x is greater than b, so this will be f of a minus. So this is a slight change in the answer. In the next example, we will take the binomial distribution and then we will write the distribution function of it. So this question says for the experiment of flipping a fair coin, if we are given it is a fair coin. Twice, and we have so we have to write the distribution function x. So we know that we have the probability that head and head, head and tail, tail and head, tail and tail. Since we are P, which is probability of head, will be half and probability x is equal to 0 means we have not observed any head, so it will be 1 by 4. Probability similarly for obtaining at least for obtaining exactly one tail is 2 by 4, which is nothing but half, and probability that x is equal to 2 means we are getting all tails will also be 1 by 4. So this is the way we can write the corresponding probabilities. Now we will plot the distribution function. How we can write the distribution function for this? So for f of x will be defined as, it will be 0 for all x less than 0. For x less than 1, what is the probability of? Now for x lying between 1 and 2 with the equality at 1, so there are 2 by 1 by 2 by 4 plus 1 by 4, it is 3 by 4. And what is the probability of x is greater than equal to 2? It is 1. So this is the way we have I will try to plot this distribution function. So x is equal to 0, x is equal to 1, and x is equal to 2. So we know that at x is equal to 2, we are getting, once we reach there, if this is corresponding one probability, then it will go like this. be somewhere like this at 1 by 4. For x is equal to 1, we will have the distribution function as 3 by 4. So it will be like this. It is 3 by 4, and so the distribution function is now plotted like this. So this will be the distribution function with jumps at x is equal to 0, x is equal to 1, and x is equal to 2. And for x is equal to, once it reaches x is equal to 3, it is unity. So all for this is the way we can write the distribution function for a random variable x, which is defined as the number of tails in flipping of a fair coin. So this is the way we have written the distribution function of a random variable. And now we will take another example. So the next example says that gx is a distribution function which is defined as 0 for x less than minus 1 and 1 by 2 for x is less than 0 and greater than equal to minus 1, and a plus b e to the power minus of x square by 2 for x greater than 0. So we have to find the values of so that gx is a distribution function. So where from here we see that g of at minus infinity is given as 0 and g at plus infinity should be equal to 1. So if we substitute here, we get a plus b to the power minus infinity, which is a. So we get the value of a as 1. Now let's see what is the value of g at 0. and g at 0 plus. So we from here we see that g at 0 is half and g at 0 plus. If we substitute x is equal to 0 in this, so we get a plus b is equal to half. So from here we have got that b a plus b is equal to, sorry, and b will be equal to 1 by 2 minus a. So 1 by 2 minus a is 1. So we get the answer minus 1 by 2. So our gx takes the form of 1 minus 1 upon 2 e to the power minus of x square by for x greater than 0. Okay, so this way we obtain two constants a and b, for which determine whether the given distribution function will be satisfying all the properties of being a distribution function at g at plus infinity, g at at the point 0. So with the help of this, we got here two constants a and b. Now we will take an examples of order statistics, and we will show that the distribution function for the smallest observation is also a distribution function. So this question says let f(x) is a distribution function then show that gx, which is defined as gx is also a distribution function where gx is given as 1 minus f of x whole to the power. So this is basically the small distribution function of if n observations are obtained from a random variable having distribution function f of. So basically gx is the distribution function of the smallest observation, and now we will establish that gx, which is defined as this, is also a distribution function. So first we will see whether we know that we are given that f of x is a distribution function. So for suppose x1 is greater than x2, we see that since fx is also increasing function, so we write it as f of x2. Now we are starting from this point, and then we will go from this point to this point, and we will change the sign of the inequality accordingly. So first if we multiply this inequality by -1, so the inequality sign will change. So it will become so I'm adding 1 both sides, which will not which will not change the result, and we take the nth power of this. Where n is a positive number. Now we again multiply both the sides, and we get the desired result that so this becomes g of x at 1, which is less than equal to g of x2. So we established that gx is non-decreasing. So this is the first part. We established that gx is non-decreasing. Now we see that what is the value of g of x at minus infinity. So if we write minus infinity limit x tends to minus infinity 1 minus 1 minus f of x to the power. So we get 1 minus limit x tends to minus infinity f of x at x whole to the power. So this term will become 0 because f of x at minus infinity is nothing but 0. So we got 1 minus 1, which is 0. So our first point is established. Now let's see g of x at plus infinity. So we will take the limit x tends to infinity of 1 minus f of x to the power n. So 1 minus f limit f of x to the power n. So we know that at x is equal to infinity, this will become 1. So this will be 1 minus 0 to the power n. So this is 1. So we also concluded that gx is in plus 1 at infinity, plus infinity. Now we will see whether g of x is right continuous. So for that we will take g of x plus 0, which is limit x tends to 0 1 minus f of x plus h to the power n. Okay. Now we will since limit is distributed, so we will take 1 minus f of x plus h whole to the power n, and limit will be here. So since we know that the fx is distribution function, so f of x plus h will be equal to f of x. Okay, so we will get 1 minus f of x to the power n. So this is nothing but this is g of x and x. So we see that g at x plus h is equal to g of x of x. So we proved that gx is satisfying all the properties of being a distribution function. So gx, which is defined as this, is also a distribution function. So we will discuss this distribution function, and we will be discussing the order statistics, and we will have the distribution of the smallest observation. We will derive its distribution function, and also it is the smallest observation, and we will also draw the distribution function of the largest observation. So today I stop here, then we will meet in the next lecture. Thank you everyone for watching.